In this video, I will demonstrate problem D on diagramming interactions and forces. So in problem D, we have a block is on a ramp but not sliding. So that tells me that it's at rest. And go ahead and get a start on your system schema diagram showing all the objects and interactions. And then pause the video and then come back and check and see if what you have agrees with what I have. So when I think about the objects, I can see that there's a block and there's a ramp, and then we're probably on the earth. And I think that's all the important objects. Now the block is going to be interacting with the earth through a gravitational interaction. And the ramp is also interacting with the earth, but we don't need that for our situation because we're just really focusing on the block's interactions. And the block is interacting with the ramp because it's in contact with the ramp. Now, when something is in contact with a surface, we have to think about what's happening, what kind of interactions are happening. Well, these surfaces are pressed together, so the bottom surface of the block and the top surface of the ramp are pressed together. And so this is going to cause a scrunching of those little atoms and molecules, which is going to cause the surface of the ramp to try to expand this way, and it's going to cause the surface of the block trying to expand that way. So we have a scrunching kind of interaction happening. But interestingly, the block is also not sliding. So if this was a perfectly smooth surface, we would expect the block to be sliding this way. But because the block is not sliding, there must be friction going on. And since the block is not sliding this way, friction must be pulling it back that way. So friction is pulling this way on the block, and then the bottom edge of the block is dragging the molecules of the surface this way a little bit. So we have a friction interaction occurring also between the block and the ramp. So those are all of our interactions, and our focus object is the block. And our next step is to draw the free body diagram in this square over here for the block. So represent the block as a dot. And when you have situations that are just horizontal, like this one up here, or situations that are completely vertical, you don't need to necessarily draw your coordinate system over here. But when you have something on a ramp, you really need to draw the ramp so that you can get your forces going in the correct directions. So I'm going to show the ramp like this. That's the surface of the ramp. You can draw the whole ramp if you want to. Just kind of sketch it in lightly, and that will guide us when we want to draw our forces. So what forces do we have? Well, if we look at the boundary here, we can see that there are 3 lines crossing that boundary. So there are 3 different interactions occurring, and each one of those will relate to a force that's on the block. So let's do the force of gravity first. The gravitational interaction, it's always going to be straight down or towards the center of the earth. So let's draw an arrow for that. And this is the force of the earth on the block. Okay, so that took care of this one. Now we have this scrunchy interaction where the molecules of the block and the ramp are squishing each other because they're being pressed into each other. That is the scrunchy force, we're calling it for now. And that force, the direction of it is always perpendicular to the surface because those little molecules are trying to expand that way, and the molecules on the block are trying to expand that way. So the surface, as it's trying to expand, it's going to expand away onto the block. So the force on the block will be this way. Okay, that's perpendicular to the surface of the ramp. So this is a 90-degree angle here. Okay, and this is the scrunchy force. This is the force of the surface on the block. And that has to do with the fact that those atoms got scrunched. Now the other force, friction, is occurring because of a shearing that's happening to the atoms, a dragging between the atoms on these two surfaces as the block tries to slide down and is not able to move. And that force is always going to be parallel to the surface, and here the surface is at an angle, so that force is this way, parallel to the surface and opposite the direction that it's intending to go. It's intending to slide down, and so the friction force is opposite that. So we would label this as force of surface on block, and in parentheses friction. And that's due to a shearing kind of a force on the molecules. As for the lengths of these arrows, we don't have a good way at this point in our study to know how long they are. The object is at rest, so somehow these forces are balanced, but we don't know yet how to add them up to see that they're balanced and to see that if we added them up, they would add up to 0.